Okay, I think it is visible. Huh? Okay. Yeah. So in my last class, I've discussed what is electric field. I briefly talk about what is electric field. Okay. So let's take a look of our previous class so that we can start the point from where we left. Okay. So till now we have studied what is Coulomb's law and what is electric field. And what is electric field? Due to we consider a charge capital Q, and due to electric field due to this charge at a particular distance r. So for that we take a test charge, we bring that test charge very close to that particular source body in that electric field region of that source body, and after that we find a formula, a relation of electric field. Okay, what is that electric field? If I consider a source charge, capital Q, okay, and if I consider a small test charge, okay, and that is separated a small r distance from this source capital Q, that is, this is our source charge, and this is our test charge. Okay, so in this case this small q charge basically experiences a force, and in that case the force is, as you know, 1/4 pi epsilon naught k q small q divided by r square. Okay, so that is a force, and from this force we can measure the field. What is the field? The field, electric field, is equal to this force divided by a small q. Okay. But there is a limitation on over this small q charge. What was that limitation which I told in my last class? Anyone? Minashi, what was the limitation over this small test charge? What was the limitation?
Q is equal to 0.
The limit q tends to 0. Q is not equal to 0, because if you put q is equals to 0 in this equation, then the electric field goes to infinity. Okay, the limit q tends to 0. Limit q tends to 0 means the test charge should be very small, so that your source charge will be fixed. And one more thing, that this the electric field of this small test charge wouldn't affect the electric field of this source charge, because you are measuring the electric field of this source charge. Okay, so this is the formula of electric field, which is F upon Q. For numerical purpose, we will consider the formula E is equals to F upon Q. For numerical purpose, we will consider this formula E is equals to F upon Q. Okay, E is equals to F upon Q. But for your, if somebody asks, if there is a question in your examination that define electric field, so in that case you will you write this formula, which is electric field is equals to limit q tends to 0 F upon Q. Okay, F upon Q. So this is our formula for our numerical purpose. E is equals to F upon Q. Okay, and the direction of electric field, I also discussed what is the direction of that electric field. The direction of electric field is same as the force. The direction of electric field is same as the force. Okay, I think these all the points I already discussed in my last class. In my last class I stopped at this I already discussed what are the directions. Okay, the direction is along as the direction of force. Okay, for positive charge it's away from charge, and if for negative charge is towards charge. That direction is towards charge. Okay, so these are some points These are some points which we considered in our last class. Okay. So now let's do a very small problem over this formula, which is E is equals to F upon Q. Suppose a test charge. Suppose a test charge of 10 raised to the power minus 3 Coulomb. It experience a force of 10 raised to the power 2 Newton due to field of source charge. Due to field of source charge. Okay. Calculate the magnitude of the field. Calculate the magnitude of electric field. So all of you try to solve this question. The formula is E is equals to F upon Q. Okay. Now try to solve it. It will take hardly 1 minute. Maximum 1 minute. 1 minute question is. It's a very short objective question. It will take hardly 1 minute. Okay. Try to solve it. Is it clear? What is given in this question? What is given? Abdul Rahman, what is given in this question?
Charge is given.
Huh?
The charge is given.
The charge. Which charge? Source charge or test charge?
Test charge.
Test charge. So test charge is given, which is Q is equals to 10 raised to the power minus 3 Coulomb. Okay. And Minashi, another quantity which is given here? Force is also given here, which is 10 raised to the power 2 Newton. From over this two information, you can find the electric field. Now tell me the electric field. What is the electric field? As I told you, you can use the formula for electric field is E is equals to F upon Q. So what is the answer? Tell me. Give me a message. Somebody send me a message. Yeah, 10 raised to the power 5. That's correct answer. And what about you, Abdul Rahman? So here the answer is E is equals to, that is F upon small q. So that will be 10 raised to the power 2 divided by 10 raised to the power minus 3. And this is Newton, this is Coulomb. So that will be 10 raised to the power 5 Newton per Coulomb. That is our electric field. This is only magnitude. Okay. Now next we are going to find an electric field due to a point charge. So now take a heading, electric field for a point charge. What is the electric field for a point charge? So electric field for a point charge. Okay. Now let's try to find this electric field. So for a point charge means, I already told you what is a point charge. What is a point charge? How can you define a point charge? Tell me, Minashi, what is a point charge? How can you define a point charge? Means what is point charge? But I didn't get your answer. Please explain again. Yes or no? Means you have idea. I already discussed this. What is a point charge? Abdul Rahman, do you know what is a point charge?
It's a very small charge.
A very small, actually not, you can say very small, a body which has 0 dimension. Means if a line has a 1 dimension and a surface has a 2 dimension and a sphere has a 3 dimension. And I am here talking about a 0 dimension particle is considered as point, and the charge over that particle considered as your point charge. Okay, so here I'm taking a point charge. Suppose a point charge is your capital Q is your point charge. Okay, and at r distance I am putting a test charge. This is our test charge Q. Okay, and the displacement vector is vector r between these two quantities. Okay, and this is a positive Q charge, and here test is charge is also positive. Then this will experience a field over this direction. This is F. Okay, and now what is the value of this force? What is the value of this force? The value of this force is, you can find the value of this force. F is equals to 1 upon 4 pi epsilon naught, 1 upon 4 pi epsilon naught, that is capital Q, that is small q, divided by r square. And what will be the direction? It's a positive r cap, or should I take negative r cap? Meenakshi, what will be the direction? It's a positive r cap or it's a negative r cap?
Positive.
Positive r cap, because that force that will this plus q charge will experience is in the right hand side direction. Okay, if it's in left hand direction, then we consider it's a negative r cap. Okay, so now the electric field of source charge is vector E is equals to limit q tends to 0 vector F divided by q. Okay, so here limit q tends to 0, put the value of F here. So 1 upon q, what is the value of F here? 1 over, substitute this value, 1 over 4 pi epsilon naught, that is capital Q, that is small q, divided by r square, and it's r cap. So here this q and q will get cancelled out. This q and q will get cancelled out, and if there is no q, so there is no meaning of limit. Okay, so in our next step, I can write as this electric field is equal to limit q tends to 0, 1 over 4 pi epsilon naught. This is our capital Q divided by r square, r cap. So we can remove this quantity. We can neglect actually this quantity because there is no q inside. So there is no meaning of this limit. So the final expression of this electric field is 1 over 4 pi epsilon naught capital Q divided by r square in r cap. So this is the electric field due to a point charge. This is the electric field due to a point charge, due to a point charge. Point charge. Okay. Write it down, take a note. This is the electric field of a point charge. Always remember this this formula. If I ask you what is the electric field due to a point charge, then always reply that is 1 upon 4 pi epsilon naught capital Q by r square, or you can also say that it is K capital Q divided by r square. So here you can see that the electric field depends on source charge and the distance where you want to calculate the electric field. Okay, so there is dependency over the source charge and the distance, which is r. Okay, which is r, distance, or you can better say displacement. Okay, So these two things here, E is inversely proportional to R square. You can see that directly proportional to 1 by R square. Okay. So this is all about electric field due to a point charge. Now let's okay, is it, have you taken the note? All of you, should I go to our next concept? Okay, so let's go to the next problem. Let's go to the next problem. Okay, Maziha and Saifullah recently joined us. So let me give a very small recap to these two peoples. Okay, Muhammad Saifullah and Maziha. I'm giving a very quick revision of our concept of this point charge, electric field due to a point charge. Okay, so okay, so till now we have discussed what is the electric field for a point charge. If I consider a very small body, zero dimensional body, so for that what is the electric field? So here this is the Q, which is source, or we consider it as a point charge, okay, and this is a small positive plus Q charge, which is test charge, and the force for this system is 1/4 pi epsilon naught capital Q divided by capital Q into small q divided by R square. Okay, so from this formula F we can find the electric field. As I told you in my previous class, that electric field is equals to limit Q tends to 0 F upon Q. So when I put this the value of force here, so what happened, this Q and Q will get cancelled out, and finally you will get expression which is electric field is equals to 1/4 pi epsilon naught capital Q by R square. This is the expression of electric field due to a point charge. This is the expression of electric field due to a point charge. Okay, so and the direction, as I told you, the direction of electric field is same as the electrical force. The direction is same as electric field as force. The direction of force is r cap, so as the direction of electric field is also r cap. Okay, now let's do a problem over this concept. Let's do a problem. So question is like, if charge of +2 Coulomb, a charge of +10 Coulomb at origin calculate the electric field, at calculate the electric field at a point capital A, which is 3, 0, 0. Okay. So in this case, find magnitude and its direction. Okay, so this is the problem. Now let's try to solve this problem. Okay, now let's try to solve this problem. A charge of +10 Coulomb at origin. Okay, calculate field at, this is at, calculate electric field at a point 3, 0, 0, and you have to find them what is the magnitude as well as direction. So what is the mean of this origin? Origin means if I draw a graph if I draw a graph, so what in graph, what are two axes? One, we consider one axis, which is, what are two axes? Minashi, what are two axes in a graph?
X and Y.
X and Y axis. Okay, so both are perpendicular. So if I draw a graph, so these two are axes. Okay, these two are axes. So tell me, Saifullah, the horizontal axis is X or Y? The horizontal, this one axis we consider is X or Y?
X.
We consider this axis as X axis and this is our Y axis. We consider this X as the input axis or Y as the output axis. And here the origin lies somewhere here. This is our origin. Okay, this is our origin. So here, at this origin, the point is located. The point charge is located at this point, which is 3, 0, 3, 0, 0. Means 3 denote the x-axis. Okay, and 0 denote the y-axis, and z denotes the basically z-axis. These are 3 axes. Okay, these are 3 axes. So here it's a one dimension, means only x-axis is here, which is 3. Okay, a charge of 10 located at origin, calculate the, and you have to find, I'm sorry, this 3 is where you have to find electric field, and you have to find electric field which is 1, 2 and 3 point. Okay, this is our 3, 0, 0. 3, 0, 0. You have to find electric field at this point. Okay, you have to electric field at this point. Here is your charge, source charge. Here is your source charge. Okay, here is your source charge. This is your source charge. Yeah, this is your source charge. Okay, which is 10 Coulomb. And at this point, you have to find what is the value of electric field. What will be the electric field at this point? So here, this distance is your basically 3. It is given here. Okay, this distance is your 3. So now here, what is the value of r? So you can use the formula of your point charge formula. What is the formula for point charge formula? What is the expression of point charge formula? It's E is equals to 1 over 4 pi epsilon naught. This is source charge, which is capital Q, divided by R square. Now tell me, what is the value of Q? What is the value of Q here? Abdul Rahman, what is the value of capital Q here? 10 Coulomb. Okay, and what is the value of R here? Saifullah, what is the value of R here?
3.
3 is our the distance which is given here. So now all the values are given here. Now you can find out what is the exact value of your electric field at this point, which is located at a unit 3 distance from the origin. Now tell me the answer. Just substitute this value into the formula, and you already know what is the value of 1 over 4 pi epsilon naught. I already told you what is the value of this 1 over 4 pi epsilon naught. Now tell me the answer. Then we will discuss what is the direction of this electric field. You can send the answer in chat box. Okay, somebody send me the answer. Okay, it's correct. Abdul Rahman, send me the correct answer. No. Oh. And other guys, try to solve it. Yeah, one more message. Yeah, it's correct, Saifullah. Wait for others. So, and who solved? Minashi, your answer is not exactly correct. Try to revalidate it. And who find the correct answer? Try to think about its direction. What will be the direction? What will be the direction of this electric field? As I told you, the direction is same as the direction of force. And it's what is the exact direction of this electric field? Then I will discuss what is the direction at its correct magnitude. Most of you find the correct answer. Yeah, Muhammad Saifullah send me another message, which is yeah, it's a correct answer with the unit. Okay, but I'm asking about direction. This the direction of this electric field. It's in x-axis or along y-axis, means we consider it for I cap, or we consider it for j cap. Anyone? Anyone who find the direction? Yeah. Yeah, it's correct. Saifullah send me the correct answer. What about others? Okay, one more message. Maziha, but where's your answer? You haven't sent me the answer. Are you facing problem in solving this question? Huh? Maziha, you are not replying. Hello? Yeah. Okay. Okay. So let me explain you what is the exact solution. What are the directions and your magnitude. Okay, wait for a minute. I think my screen is not shared right now. I'm just sharing my screen. Wait for a minute, guys. Okay. Okay, one thing I have to announce that in my next class there will be a viva. There will be a oral viva. Over the topics are actually the Coulomb's law and this electric field. You can say that electric force and electric field. Okay, so over that viva I will ask questions. Okay, I will ask question in our viva. Okay, so prepare these two topics. The one is your electric force and the another one is your electric field. So in that you prepare what is electric force, what is magnitude, what is your permittivity. Okay, permittivity of free space and absolute permittivity, relative permittivity. Okay, all these things you prepare for your viva. And you, what are electric field, what is the relation between electric field and electric force, and another uh, electric field for a point charge. Okay, and electric field for system of charge, leave that, because I think today I will discuss what is the electric field for system of charges, for superposition principle, that I will discuss today. So you just prepare two things. The one is your electrical forces and another one is your electric field. Okay, so prepare viva for your next class, which for your Monday class, next Monday class. Okay, and wait for me, my screen is not getting shared, I'm just trying. I'm really sorry for this inconvenience due to these technical issues. But wait for a few minutes. I'm just shorting. Okay. So finally it worked. I'm really sorry, students. I'm not able to sort out my problem, my technical issue, because it's taking more time and you guys are waiting. So yeah, I think now it works. Is it visible to all of you, my screen?
Yes, sir.
Oh, finally. Okay, so I'm really sorry for this inconvenience. Please, and thanks for making patience. Now, let's solve this problem. Let's solve this problem. Uh, that is charge which situated at the source. Yeah. Yeah. So here, what is the electric field? The electric field is E is equals to what is the value of 1 over 4 pi epsilon naught? We know the value of 1 over 4 pi epsilon naught is 9 into 10 raised to the power 9. And here, what is the value of this Q? The value of Q is 10 and divide by its 9. So here you can remove this 9 to this 9. So here 9 and this 110, that is 10 raised to the power 10, and the Newton per Coulomb is our unit. So this is our electric field. This is our electric field. Now, if we talk about the direction, so the direction is, this is our source charge Q, which is 10 Coulomb, and you have to find the electric field in the direction of your x. So you can consider the direction as your I cap direction. I cap direction, because it's in x direction. The field is in x direction. If the field along y direction, then in that case we consider j cap, and if the field along z direction, then in that case we consider k cap. Okay, so these are unit vectors along x axis, y axis, and z axis. These are the unit vector along x, y, and z axis. Okay, so this is the answer of this question. Now tell me, Maziha, is it clear for you? Because you messaged me that you didn't get it. So here what we did, but we first calculate electric field, and to calculating electric field we use this formula, E is equals to 1 over 4 pi epsilon naught Q by R square, and everything is given here. We put the value Q as a 10 Coulomb, the value of R as a 3 unit, and after that we get the answer. And for direction we take I cap is the direction, because the field is along x axis, 10 raised to the power 10 Newton per Coulomb I cap. Okay, so this is all about our electric field due to a point charge. Now next topic is, if you want to find the electric field for system of charges, if you want to find the electric field for this is only for a point charge. If you are trying to electric field for a point charge, in that case this formula works. And for a system of charge, means suppose a charge situated here, and a charge situated here, and a charge situated here. So these are 3 charges. So for this system of charges, what will be the electric field? Okay, means if I put a charge Q here, suppose Q, then what happened, electric field in somewhere this direction plus Q, then electric field will be in this direction. If I talk for center, if I want to find electric field at this center, and for this plus Q charge, the electric field like in this direction. Okay, so there are a lot of electric field, and every electric field has its own direction. So what will be the net electric field at a particular point due to system of charges? For that we required superposition principle. But before going to the superposition principle, first I must have to know that all of you have a clear knowledge of vectors. And a clear idea about the direction of vector, addition of basically two vectors. This time we don't need the multiplication, but you must know what is the addition of two vectors. Okay, so for at this moment I will discuss some mathematical topics related to vectors before going to our superposition principle, which is our next topic. But here I'm going to the vectors. Okay, vector is not in your syllabus, but is required for your understanding of electric field. Okay, here up to now we discuss only one direction of electric field, but if you are considering more than one direction, then you have a very clear idea about how two or more than two vectors get added, so that you can easily get this topic. Okay, so for that, let's discuss what are vectors. Okay, vectors are basically the addition of vectors. Okay, suppose vectors, or we can say that addition of vectors. So suppose I have a vector which is in this direction. Suppose I have a vector in this direction. This is, I'm considering a vector A. Okay, and now I'm taking another vector which is like this one. This is our vector B. Okay, so there is a rule which we call parallelogram rule for addition of two vectors. So what is that rule? So the resultant of these two vectors will go somewhere here. We don't know exactly, but it will go somewhere here. Okay, somewhere here. Okay, but before discussing what is the resultant, first I am going to draw a parallelogram which associates with these two vectors. Okay, so suppose I draw a parallelogram. Okay, so the parallelogram will be like this one. Here is your parallelogram, and here this is a parallelogram. Okay, what is the parallelogram rule? So the parallelogram rule says that if we add these two vectors A and B, then resultant must be goes the diagonal of this parallelogram. This is our resultant of addition of these two vector A plus vector B. Okay, is it clear? Now next, what will be the magnitude of this, the formula of magnitude of this resultant? If I talk about what is the magnitude of this resultant R. Okay, what is the magnitude of this resultant R? So the magnitude of this resultant of R, Abdul Rahman, do you know what is the resultant of this R?
Yes, sir.
Tell me.
Sir, under root A square.
Under root A square plus B square. Is it a general form? Plus, okay, 2AB, and next cos theta. Very good, cos theta. This is the expression to find the magnitude of two vectors. Okay, and what is theta here? Theta is the angle between these two vectors. Okay, not about the resultant. Theta is the angle between these two vectors. Okay, so here this is our resultant, and if we talk about the direction, then the direction we can say that the magnitude is taking some direction like somewhere here. So we can find the angle of your magnitude from vector A, or you can find the vector from vector B, and from that we can find what is the exact direction. So this is the formula for your magnitude. For addition of two vectors. If you want to add two vectors, then this formula works. Okay, now let's take another set. In that set, I'm considering two vectors. One vector is vector A, and another vector is also vector A. Another vector is also vector A. Okay. Another vector is also vector A. And in this case, I'm taking these two vectors are perpendicular to each other. These two vectors are equal and these two vectors are perpendicular. Then in this case, what will be this parallelogram will be? What kind of shape this will do? If these two vectors are equal and perpendicular to each other, what this parallelogram look like? Huh? Minashi, can you tell me?
Yes, sir.
What is the shape? Huh? Hello? What is the shape? Hello?
Yes, sir.
No, your voice is not actually clear. I'm not understanding what you're saying. Okay, so it will be like a square. Okay, and in this case, if you find magnitude of the resultant, the magnitude of this resultant, what is the value of this magnitude of resultant? That will be under root. Here a is equals to b, so that is a square plus b square, which is also a square, which is also a square plus a square plus 2a square into cos. What is the value of cos? Is pi by 2. So what is the value of cos pi by 2? Anyone? What is the value of cos pi by 2? What is the value of cos pi by 2? Abdul Rahman? Abdul, are you listening me? What is the value of cos pi by 2? Give me a quick answer. Or Minashi? Okay, somebody
1.5, sir.
send me message. Yeah, it is 0. Yeah, exactly. It's 0. The value of cos pi by 2 is 0. So here, the value of cos pi by 2 is 0. So here I can write a square square is square root. So from here I can have a under root 2. This is our answer. This is a resultant. And what will be the direction? So if both vectors are equal, so in that case, the resultant will go from its center. Okay, the resultant will go from its the resultant will bisect exactly the angle between these two vectors. Means in this case, this angle will get 45 degree and this angle will get 45 degree. Okay, is it clear? So this is a parallelogram rule. If both vectors are equal, then the resultant will bisect the angle between these two vectors. Okay, and next one more thing related to this. If suppose the angle between these two vectors is 0. Suppose a vector, the angle between these two vectors is 0. Suppose I'm considering a vector A and vector B. Suppose I'm considering a vector A and vector B, and if the angle between these two theta is 0, means they are in same direction, then what will be the resultant? Suppose a vector A is also in this direction and B is also in this direction. Suppose this is our vector B. So what will be the resultant in this case? So the resultant will be, again, you can write as under root a square plus b square plus your 2ab into cos 0. What is the value of cos 0? The value of cos 0 is 1. So you can put here under root a square plus b square plus 2ab. So from here your resultant is your a square plus b square is a complete it's a plus b whole square, complete whole square. It's a plus b whole square and also under root. So in this case this under root and whole square will cancel out. So your magnitude of r is just the sum of vector a plus b. Okay, so if two vectors are parallel in the or theta is 0, so in this case the magnitude, the resultant of magnitude is simply you can add that two vectors. So two cases which we discussed, which are very important for our next problem and next topic, that if two vectors are perpendicular, then in that case the resultant will go, the direction of resultant, or you can say that the resultant will bisect the angle between these two vectors. And if two vectors are parallel, then in that case the resultant is just the sum of these two vectors, sum of magnitude of these two vectors. Okay, and direction is also already same. Direction is already same as the direction of a and b. These two cases I discussed in very short, in a very short way, so that you can get a very small idea, a very quick idea of addition of vectors, how vectors get added. It's not vectors that doesn't add in a simple way, you know. A vector doesn't add it in a simple way, means it's not algebraic sum. 3 plus 5 is 8. It's not an algebraic sum, it's a vector sum. So in vector sum, quantity is not as usual like scalar quantities. Okay, it gets changed. It also depends on its angles and other things. Okay, one more thing I have to discuss about vectors is a resolution of vector. The next thing which I'm going to tell you is resolution of vector. How to resolve a vector in its component form. This is another point. This is another topic. Okay, suppose I draw a axis. This is my x-axis and this is my y-axis. Okay, this is x-axis and this is my y-axis. Okay, and if I draw a vector, which passes through a origin and making an angle theta, okay, so in this case what will be the horizontal and vertical component of this vector? Suppose this vector is your, here this is point P and this is your vector R, or you can say any vector displacement vector. So how you can define in terms of its vertical and horizontal component? How you can define it in terms of horizontal and vertical component? Okay, so suppose this is our vector R. So I can draw a perpendicular here. I'm taking this axis as a capital X axis. This is our axis, and this axis again capital Y axis. Okay. Now next, if I draw a perpendicular over these 2 points, this is our vector R. How can you resolve this vector R in its component form? Okay, and suppose this distance is your horizontal intercept, which is small x, and this is our vertical intercept, which is small y. So how can you resolve this vector R in your vertical and horizontal component? What is the value of this? Means we have to calculate OA and OB. We have to find what is the value of OA in terms of R and what is the value of OB. So that is we called how to resolve this vector in its horizontal and vertical component. So the question is how to resolve a vector in its horizontal and vertical component. Okay, then it's you can compare from addition of vector, means this, you can see that this is just previous case, means every vector which is in a certain direction is, you can consider it as addition of two vectors. Okay, that we will do simply. Yeah. So what we are going to do, we will use some trigonometries. Okay, so for trigonometry we can write cos theta and we can write sine theta from this right angle triangle. On this right angle triangle we can find sine theta and cos theta. Okay, so for this right angle triangle, what will be the value of, first try to find sine theta. What is the value of sine theta for this right angle triangle? This is our angle theta, and what will be the value of sine theta? So what will be the value of sine theta? Sine theta is the perpendicular which is PA, the perpendicular which is PA is divided by its hypotenuse, which is your OP. Okay, sine theta is equals to PA, which is your perpendicular distance, and OP, which is your hypotenuse. Okay, is it clear? Okay, now next, what is the value of PA? What is the value of PA here? What is the value of PA here? What is the value of PA, Abdul? Abdul is not, I think he has problem. What about PA? Any other? Shafullah, can you tell me the answer? What is the value of PA here?
Y.
What is exactly? It's a small y. Okay, it's a small y divided by OP. OP is R. OP is our hypotenuse, means diagonal value, and which is R. Here I'm talking about only for magnitude, so R. Okay, R. So y by R. So here you find the value of y, which is our vertical component, is R sine theta. It's R sine theta. So you can write this horizontal, this distance, vertical distance, as R sine theta. Okay, and another horizontal, what is horizontal? For horizontal we can take cos theta. We can take as cos theta. So can you tell me what is the value of cos theta here, Minashi? What will be the value of cos theta here? As I write, sine theta is equals to PA upon AP. So what is the value of cos theta here?
Yes, sir.
For this right angle triangle, what will be the value of cos theta?
30
No, not, it's not in angle, means it's a simple trigonometric, no? Means, as you know, sine theta is equals to your perpendicular upon hypotenuse, same as your sine theta is, yeah, Abdul Rahman again answered, OA upon OP.
opposite
Okay.
by ear.
That's correct. Is a base upon hypotenuse. So cos theta is your base upon hypotenuse. So here base is OA. So here base is OA, and your hypotenuse is your OP. Hypotenuse is OP. So here OA is your X and OP is your R. So from here you can find your value of X. X is equals to R cos theta. R cos theta. Okay. So here you resolve this vector in its horizontal and vertical component. Your vector R, and the magnitude of this is magnitude of R, and the your vertical component is R sine theta, and your horizontal component is your R cos theta, which is your X and your Y. Okay, is it clear? This is actually very important, because in electric field, whenever you have electric field, you have to resolve it in its vertical or horizontal component. Okay, and whenever you have two electric field and you have to find the resultant of the electric field, so for that you have to apply that addition rule. Okay, so these are actually very connected. Resolution of vector and addition of vector, actually these are same thing. Okay, is it clear? Take a note of this resolution of vector. This is our x-axis, y-axis. Is it okay? Have you noted down? Or you are writing? Yeah, one message I am reading. Sir, Viva portion are electric field and electric forces. Yeah, you have to prepare Viva in your next Monday class, and in that class I will ask few questions related to electric field and electric field. These two topics I will consider for Viva, because so that I will get that what's your means you are getting my lectures, what are you understanding through my lectures, and what's your current status. Okay, so for that actually we will do a Viva on Monday. Okay, so be prepare for the Viva, and after that we will discuss more thing. If you if you're not able to answer some question, then don't worry, we will discuss it in more brief way. Okay, so that your points gets more clear. So now I think you are ready to understand what is superposition principle. Any other query or question related to vector? I just discussed two concepts related to vector, because at this particular time, at this particular point, these two points are actually very important and very useful for understanding this superposition principle. Otherwise, you will not get what is a superposition principle. Okay. If you have any question, then you can ask related to vector, means for addition of two vectors. I think this will be enough for our this electric field. Okay, and I think in your previous classes you have done a course on vectors. In your 11th class you have already done a course on vectors, but here I just give you a very quick recap of your vector. Next, I am discussing what is your superposition principle. Superposition principle. Okay, so one more thing I have to tell you before going to the superposition principle. Wait for a minute for let me ask one or two question related to this resolution of vector. So suppose I am taking a vector again here, some few questions so that for better understanding of this vector. Suppose I am drawing here axis x and axis y. Okay, and in this case I am taking a vector. Suppose I am taking a vector here, vector a. Here I am taking a vector a. So, and this is making angle theta. So tell me what will be its vertical component? Tell me, Saifullah, what will be what is the vertical component?
A sin theta.
A sin theta. A sin theta is its vertical component. A sin theta is vertical component, and A sin theta is its A cos theta is its horizontal component. Then always remember the point you are considering, the component you are considering which is just in front of angle is your vertical component. Every time the angle which is the component which is just in front of theta or angle is your vertical component, and another one is horizontal. So I'm giving a very short problem. Suppose I'm choosing a vector this time, a vector of magnitude. Suppose this is a vector A, vector R, which has a magnitude of 5 unit, and it's making an angle 60 degree from its horizontal. x and y. Okay, so find the horizontal and vertical component. Okay, now give me the answer. What will be the its horizontal and vertical component? It has two components. One is vertical component, which is this one. As I told you, it's a just similar as your above example, but here I consider some numbers. So try to solve it. And give me answer. Abdur Rahman, have you find it? You can give me the answer in terms of sine or cos also. It has two components. One is vertical and one is horizontal. Minashi, have you solved it? It's a, I think, 30-second question.
Yes, sir.
What is the answer? What is its?
So 5/2 and 5 root 3/2.
Exactly. But what is vertical component?
5 root 3/2.
Okay. So here I'm explaining. So this is your vertical component. Vertical component is 5 sine 60 degree, and your horizontal component is 5 cos 60 degree. Okay, and the value of sine 60 is root 3/2. So this is 5 root 3/2, and this is your the value of cos 60 is 1/2. So 5/2. So here the vector is your 5 unit, and it's making angle 60 degree with x-axis. In that case, you find it's you resolved it. Its vertical component is 5 root 3/2, and its horizontal component is 5/2. Okay. Okay. And one more question I'm giving you. Suppose I am taking a suppose I am taking a vector 5 unit, okay, and another vector of vector 3 unit. Okay, so find in this case find the resultant. Now try to solve it. Give me a very quick answer. What will be the resultant? Five unit and 3 unit. What will be the resultant? And the angle, I'm sorry, I meant given angle, and the angle is 45 degree. Okay, you can solve this question. Resultant of R is equals to under root a square, yani 3 square plus 5 square plus 2 into 5 into 3 cos 45 degree. What is the value of cos 45? It's 1/√2. So the answer you will get is 9 plus 25 plus and 30 divided by √2. That calculation you can. So in this way we can I just give you a very small numericals over this resolution and this addition, so that you can easily understand our next topic. So now I will discuss what is your superposition principle. Yeah, next topic is your superposition principle. What is your superposition principle. Okay, so superposition principle says that, as I told you, for a single point charge, you easily find the electric field. What is electric field is equals to 1/4 pi epsilon naught capital Q by R square. But for a system of charges or n interacting charges, the net field can be calculated through this superposition principle. Okay, what is the superposition principle? When we have a discrete number of charges, or you can say system of charges, then we find the electric field for a particular charge, and after that we will take a vector sum of all these electric field, and that we call superposition principle. Okay, so write it down. For a system having n interacting particle charges, for a system having n interacting point charges, n interacting point charges, the net field at a point is vector sum of field due to individual charges, due to the individual charges. Okay, so the statement is, for a system having n interacting point charges, net field at a point is vector sum of field due to the individual charges. First we will find the individual electric field due to individual charges, and after that we will sum or vector sum all these electric fields. Okay, so suppose we have some charges. Suppose I am taking a charge here, Q1, okay, and another charge is Q2, and again here another charge. Suppose I am considering here a charge Q3. Okay, so in this case, what will be the net electric field? Suppose the net electric field over this point. So what will be the electric field due to this charge Q1? The electric field due to this charge Q1 will be like something like in this way. This is your electric field E1. What will be the electric field due to Q2? The electric field due to Q2, all are positive charges, so electric field, the direction of electric field is outward. This is your electric field E2. And suppose what will be the electric field due to Q3? The electric field due to Q3 is like this thing. This is this point. Okay. So the electric field due to these two, the first electric field is E1, second electric field is E2, and third electric field is E3. Third electric field is E3. Okay. So the net electric field, is the vector sum of electric field E1, the direction like this, E2 and E3, E1 plus vector E2 plus vector E3. This is the net. This will give the net electric field, the magnitude as well as direction for this system of three charges. You can see, if you are interested to find the electric field due to this system of charges at this particular point, then you have to apply this superposition principle. Even you can apply this superposition principle for n number of charges, and for n number of charges the net electric field can be considered as it's E1 plus E2 plus E3 up to n number of charges, which is En. Okay, this is your En. Okay, so today I'm stopping here at this superposition principle. It's not completed yet. I just today I just give you the statement, and then the numericals. Then I will discuss a lot of problems over this superposition principle, so that you have clear understanding of superposition principle, and you will get the clear idea how to take vector addition of more than 1, 2, or 3 electric fields. Okay, so this is actually very important concept. From at this point, when you completely learn the how to apply superposition principle, then actually you can able to handle a lot of fields. Okay, suppose a field is going in in this direction, a field is going in this direction, so you will take, you can find the net electric field due to different electric field. Okay, this is actually very important, because in the case of electric field is not more as complicated as the case for magnetic field. Magnetic field, the direction of magnetic field lines are more complicated. But first, if you are completely understand or able to handle more than 1 or 2 electric field, then you can easily get the concept of the magnetic field also. Okay, so today I'm stopping here. In my next class will be on next Monday. This Wednesday I'm not able to take class, I'm out of station. In my next class will be on next Monday, and prepare for the Viva. Okay, prepare for the Viva. And the problem which actually I face, I have to took 1 or 2 some extra classes, because a lot of time I think wasted in my previous and this class. So to manage our time, I will take 1 extra class, so that we will run our syllabus on time. Okay, so should I stop here, or anyone has any query, or anyone wants to ask any question? No? Okay, so I'm stopping this class here at this point. Okay, Mazia, thank you, you too.
Thank you, sir.
Okay, welcome, Minashi.